Tech Talk with Matthew Dickerson. Matthew Dickerson. Tech Talk. Tech Talk. Sit back and relax. It's time to talk technology.
And it's Tony Graham here on Binjang 91.5, and I'm in Studio 2 talking to Matthew Dickerson over the internet for another great adventurous talk with Tech Talk. G'day, Matthew.
Using technology to talk about technology sounds fantastic, Tony.
It's the way to go. Now, this first subject has taken my interest because it's to do with these new, basically electric flying machines that people will be able to use to taxi themselves around and hopefully one day not have to use a car. The affordable, apparently, aerial adventure awaits in Jetson One. I might add before I go on talking about that too much, there's also a bit of a tie-up here because there's a bit of work going on here at the Binjang aerodrome, isn't there?
Definitely a bit of work going on out there, and there's some testing being done by AMSL with a machine that will be a flying machine, first of all used in medical retrievals, but eventually will be able to be used in some sort of personal transportation device. But in America, you can actually go out and order and basically buy your Jetson One. Now, the Jetson One is designed to be very much a personal flying machine. If you look at one, the capsule is a bit like a Formula One car or a V8 supercar with a roll cage on it, where you basically strap yourself in and it's designed for one person only. It is a drone type device, so you've got 4 arms that come out from that initial pod, and those 4 arms have got propellers at each end, 2 propellers at each end with a motor at each end of it. So it is designed to fly like a drone, and it's designed to be your personal way that you can transport yourself from A to B. The idea is that you won't need a pilot's license. Now, this is in America. It's legal in America to fly this. I'm not sure about any laws in Australia, but if you're in America and you had a spare US $98,000, you could buy one of these, and with a few minutes instruction, they say that you could fly it, which sounds a bit scary, but having said that, computer technology is so good now that the computer's doing most of the flying. It's got GPS on it, it's got LiDAR on it, so it can detect what obstacles might be around. It can self-land with its LiDAR, so it does sound like a relatively simple thing to fly. It'll only give you about 20 minutes of flight time, does over 100 kilometres an hour, so in a straight line you can probably get a reasonable distance there. That's probably the vicinity of 30 or 40 kilometres you can probably get in that flight time. So as a quick way to get between Dubbo and Sydney, not great, but as a quick way to get between Wellington and Dubbo, sounds like a fantastic device that you can do those short distances. It's really designed though for those places where you've got a lot of congestion, a lot of cars, a lot of traffic lights. Get up above all of that, and in a congested city, you could get from A to B quite quickly, quite easily. If you do get to the stage where it's all going wrong, flying's not great, the battery's gone flat, I'm in great peril, you can eject the parachute. You don't get ejected like you might out of a fighter jet, but the parachute comes out and the whole device, the propellers, the whole capsule that you're in, all floats to the ground nicely as long as you are more than 20 metres above the ground when you hit the eject button.
Yeah, I don't know if you know, Matthew, but there's been a fairly big breakthrough with batteries in America by a company called Amprius, and basically they've increased the density of charge in a battery per kilogram roughly 5 times, depending on which battery you want to compare it to, but typically 5 times or anywhere between 3.5 and 5 times. And that's going to make a big difference to EVs and all these flying machines relying on electricity to power them.
Yeah, that's exactly right. That 20-minute flight time I can see being extended out fairly soon to 30 minutes, 40 minutes, maybe an hour, and then it starts to become a pretty attractive device to do some local commuting around a region.
Yeah, that's dead right. Anyway, very interesting that stuff is, I thought. And getting into this topic of electricity and how it's all done, I thought I would talk about the gravity battery because they're in the line of battle for the real renewable energy mix, I suppose you might say, where there's they're talking about using giant gravity batteries versus electrical style batteries versus pumped hydro. And basically, out of the mix, I suppose, goes those big, large synchronous motors that they've been using, that they spin up, very large weights that spin up, and when the grid is lacking electricity, they plug into that and it generates electricity as it winds down. So this is a very interesting subject, isn't it?
It is indeed, and you're right. We're going to move more and more. Our whole society across the world is going to move more and more to renewable energy. Obviously, at Binjang, you've got renewable power already being generated out there as we speak, and more projects coming. One of the problems, of course, is that sometimes the wind doesn't blow and sometimes the sun doesn't shine. Some people would say, well, that's a good enough reason to forget about renewable and just keep burning coal. But other people say, we think we can solve those problems. Now, you've had big batteries constructed in the past. You've got pumped hydro. In fact, there's another pumped hydro scheme being proposed that'll be attached or just off the side of Burrendong Dam. So you've got those sort of projects out there. But the other one, which sounds like a really fascinating project, is the idea of gravity batteries. It's the same concept in some circumstances as pumped hydro. When you've got too much power, in pumped hydro schemes, you pump water back up to the upper dam, the upper reservoir, and then when you need power, you let it fall down, let gravity use that water to then spin turbines. And effectively with a gravity battery, you've got the same thing. These particular gravity batteries by a company called Energy Vault uses bricks that are 24 tonnes each. And then essentially they're connected to pulleys and to motors. When you've got too much power, they lift these large weights up. And then when you need extra power, they let those large weights fall. Now, they don't just fall crashing to the ground and accelerating at 9.8 metres per second. They're obviously controlled as they fall because they're spinning a turbine that's generating electricity. Very efficient way of doing it. You're not losing a lot of power each time you go up and then come back down. And you can start to build these anywhere. You don't need, like you do with pumped hydro, to have some sort of upper reservoir and lower reservoir. You can build these anywhere. They look like a large apartment block, and you can have them as broad or wide as you like, or essentially as tall as you like within reason. So then you start to build these, and then you don't need batteries or pumped hydro somewhere nearby. We've seen some test sites done with them in the past, but in China at the moment, we've got 2 sites under construction for a production system, and these systems they're building will be able to store 100 megawatt hours of power. So to give you an idea, that's about 3,400 homes for a day. They're not really thinking that you'll need to provide power for a full day. It's really the idea that when you've got gaps in the system, whether it be sun or wind gaps, that these can fill in those. So they're probably not going to need to power something for a full day. It'll be more hours at a time they'll need to be used. In Texas, they've got a system already that's a 36 megawatt hour system, so not as big as those ones in China, but we are starting to see more and more of these solutions, and that's exactly what they are, Tony, solutions to some of these problems that renewable energy presents.
Yeah, don't you just love it? Now, the next subject is, propellers. And you would have thought that all the technology around propellers would have already been done and dusted a long time ago. And certainly there's been some improvements over the period. I suppose in a sense you could look at the jet engine and look at the turbofans and say, well, that was definitely an improvement with the use of that kind of concept. But now they've got a new efficient type of propeller, which is very quiet. And if it's quiet, it means it's very efficient. So the quieter a propeller is, the more efficient it actually is. And these propellers are actually going to be making a big difference to the efficiency of electric planes. Now, I would have to say drones and VTOLs, planes, but also ships. It could make a huge difference. Or it actually does. They've done tests. That does make a huge difference to ships as well. So it's quite revolutionary, isn't it?
The whole concept of looking at propellers is actually a bit new. And as you say, you think, well, we've had planes around for long enough, surely we've already got it nailed and everything's okay. But I think what happened going back a long time is that when propellers started to be developed further and further, they then came up with the jet engine, and they probably slowed down development of propellers as they focused on the jet engine. But now, as we see that we'll end up with more electric planes, probably doing those short haul flights rather than doing Sydney to LA, you'll probably find those flights for an hour and a half type length flights. So they've started doing more research on this again. Now, the interesting part is that as you increase the number of blades on a propeller, so you might go up to 6 blades in a propeller, for example, you get lower noise with more blades, but you increase, you decrease the efficiency of those blades. Fewer blades gives you better propulsion, but increases the actual noise of it. So researchers at Chalmers University of Technology in Sweden have taken on this project to say, how can we get the best optimization between noise and propulsion? Because when you take away the noise of an engine from a plane, then you've got the noise of wind and the noise of the propeller. So if you can reduce that noise of the propeller, the flying experience in an electric plane should be much nicer than the flying experience in a normal traditional plane, even if it's got propellers on there. So playing around with all of that, trying to reduce the noise, trying to increase the efficiency, that's what a lot of research is being put into. And just the tip vortices that are created. So as those tips of the propellers spin, obviously they're the fastest part of those propellers. The vortices that come off that, the noise that creates, how can we reduce that? What can we do on the end of those propellers to actually change those tip vortices? And you remember many years ago when they started putting the wing tips on, that was to change the tip vortices of wings. They're looking at things like that. What sort of radical ideas can we come up with on propellers to get to the stage where we get better efficiency and lower noise? The other thing is that you're probably going to be flying these at lower altitudes because they're going to be shorter flights that you'll be going on. So again, how do we work out those lower altitudes? Increased level of air, increased air resistance at lower altitudes, but also houses might be able to hear those noises easier because they're at lower altitudes. Whole range of technology, whole range of research going on here, Tony. Fascinating area.
Yeah, I might add that we're talking about this research in the 6 blades, but there's also a new style propeller that's been developed, and it doesn't actually appear to have, well, it doesn't have the conventional blades at all. It has kind of like a blade that goes up and out and around, and it joins another blade, and there's different angles on it. And apparently this is the most efficient propeller that they've ever developed. And that's going to be applicable to all sorts of things, for ships and planes and VTOLs and drones. And it sounds like that even is more efficient than this 6-blade affair. So that could be very interesting to have a discussion about that coming up in some of our future tech talks, I would suggest.
Yeah, and one of the things that I love, Tony, is that humans are creative, humans are innovative, humans keep trying to work out how to do things better. And this is a classic area of that where we think propellers have been around for a while and we've got it pretty much under control, but there's more development, more ideas. What sort of radical ideas can you try and really change the whole dynamic of what's occurring out there? And one idea can start generating further ideas, and next thing you know, we've got a completely different design.
You've been listening to Matthew Dickerson with Tech Talk on Binjang 91.5.
Thanks, Tony.
Thanks, Matthew.
Great to be chatting to you again.
It always is.